Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at debugging your application. I've set up a small common library to allow us to display information on the screen from a program regardless of whether you're using the Windows or the console compiler. What we have on screen here is the output from our last video, the array sorting program. This program worked just fine, but what do we do when a program does not work? Well, there are different degrees of not working. Your application could fail to compile. This one is fairly painless, as the compiler will tell you which part of the application it's having problems compiling. Usually you've missed something out, like a comma, a bracket, or added in one too many. These syntactical errors are fairly easy to fix. However, your application may fail more catastrophically. It may crash completely, or it may fail to handle some data condition which you haven't taken into consideration when you designed your application. The program may do something unexpected, or may do nothing at all. So how do we track this down? Well, let's have a look at our application first of all. One of the things we've got in this application are two very important lines of code. Dim all is a good one to have because it means that your application will insist on every variable within the application being dimensioned, being referenced before you use it. This is an important line of code to keep in. This saves you having problems with typos. If you misspell the name of a variable, if you have dim all at the beginning of your program, then it will error at compile time and highlight the fact that you've referenced a variable you have not dimensioned. The second line is slightly more subtle. Debug error on is performing a specific bit of error checking while your application is running. If we have a look at the help file for this, you'll find the default for debug error is off. What having debug error on does, it means if you attempt to address an array outside of its boundaries, for example if you had a 10 element array and you try to access element number 11, then this would actually handle it for you and is very good when you're developing your program. Ideally you should not need the debug error on in a production program. So let's have a look to see what it does when we turn it off. Our application runs fine. This is because there are no errors in the program. Let's introduce some errors. In this particular program, we're reading a file into an array. Having done that, we're reading through each element of the array. Now what we're doing in here is we're outputting the values in the array to our log, and we're using the ubound, which works out how big the array actually is and runs the for next loop accordingly. However, if we put some arbitrary number in there and run our program now, what's happened? The application has actually terminated. This is very strange. It's given you indication of an error, but the program has run and then stopped. This is because we've ran beyond the bounds of this array. If we turn the debug error back on and run our program again, the application would not crash. So the best approach to handling errors is prevention rather than cure. Every time you address an array, always work out how big the array is, so you're never going to hit the problem with reading beyond the bounds of the array. However, there are some other tricks you can actually use to track down what's happening within your application. We can of course run it in the debug mode. Running our application in the debug mode gives us a variable watcher where we can actually watch every variable we actually tell it to. And you can step through your code quite happily, one line at a time. This of course can be quite laborious, but it does allow you to look at every line of code. Holding down the Shift F8 will skip over a function, allowing you to get quickly to the line of code you want. If you want to execute up to the point of a particular line of code, hit the F9 button and the line will go red. Hitting the F5 button means the code will execute right up till that point and then stop awaiting you. So from there we can see I'm currently watching long R, which at the moment is 0. If we F8 on there, and then step through the next procedure to the next long R now shows as 1. So this will quite happily allow you to right click on a variable and put it on the watch list. So here we're actually looking at the array pointed to by long R, and this is bringing up our data. So this can be a very useful method for actually working out what's happening within your application if you've identified the subroutine or function that's causing you the issues. However, there could be a problem with your application where somewhere in the application something is running really slowly. How do we work that one out? Well, there's another command called profile, which allows you to profile your application. Let's go back to pbmain. So in here we're going to put in a profile command, and we're giving it a location to where to save the profile. And if we run our application normally now, the application runs fine. And if we have a look at the folder, we now have a profile log.txt file. And if we open that up, this profile log reports how many times each of the subroutines was actually called and how long it actually spent in it. FunPrep output is the one that seems to be doing most of the work. Now you can't actually profile the pbmain, and most of the code in our application is inside pbmain. But if you have subroutines which are calling other subroutines, you can quite easily trace down which of the subroutines is actually taking the greatest length of time to execute, and that will be somewhere you can actually concentrate your efforts and actually speeding that up. Now we'll just take that profile command out. Another useful debug tool is the function name string. If in our application at some point we're actually going to be calling another routine, let's put a dummy routine in. Now this routine is not going to do anything apart from sleep. What we can do though is we can fire out a message to our log to say which function we're actually inside. This function name $ will return the name of the function we're currently in. So if we run that now, we would see each time we actually run to that function, we're throwing out a message to our log. Now this could be very useful if you're not quite sure where the program is actually executing and something has not happened. You can throw out the name of the function that's currently executing. This can be very useful for tracing down problems to find out whether has your function been entered or not, and where the program currently is. Now another command which is well worth looking at is the trace command. If we go to the beginning of our application here and we put a trace new command in, and we'll give it the name of the file we wish to trace to. And at the end of our program, we will turn trace off. Now at any point in our program, we can fire out a message to our new log of what the program's actually doing. And we'll tell it we want to turn trace on at this point in the code, and our program runs just fine. However, if we have a look inside the folder, we'll find we have a trace log, and in the trace log it's actually tracing out what the program's actually doing. It does take longer to run, but from a debug point of view it tells you exactly what it's doing. So from here, looking through the trace log, you can work out where the program got to and what it actually did. You can also put in additional trace print commands to track down exactly what the program is doing at any point in time. And there's the command we just put in. So we can actually break our program up into different sections and see how far it got. Now if you wish to turn trace off at any point in the code, a trace off command. And to take our trace out completely, we could remove all the trace commands from the code, or we could just use the tools command. You'll see the difference in the execution speed between having the trace on and having the trace off. Execution speed is markedly slowed by running a trace command, but this would normally only be done while you're debugging your program. And using the tools off command allows you to turn all the tracing off in a production program, and still allowing you to turn it back on again should any debug be needed. So this is a short introduction to debugging your PowerBasic applications. That's it for today. Thank you for watching.